And welcome everybody to the Daily Space Weather. We'll be talking about Sunspots Analyze, Integrity Uncompromised, and how you should subscribe. Or don't. Whatever you like. This is a 48-hour video from the SDO. 1700 angstroms is just extreme UV. It does have the capacity to show magnetically active regions and sunspots. So you can see a couple of dark areas here, sunspot 2835 namely, as well as sunspot 2839, which is going to spontaneously begin forming right here. And at the end of the video, you're going to actually see this start to elongate. We've also got a coronal mass ejection watch in effect. And if a coronal mass ejection does indeed happen, we'll let you know, especially if you're a patron. I'll let that play through one more time here and show a little more imagery. So here's the past day in colorized magnetogram, also from the Solar Dynamics Observatory. You're going to see some spreading and some complexification. Sunspot 2839, this one up here, has gained a little bit of complexity. It's got a leading umbra, the North Pole umbra there, racing ahead of the South Pole umbra, increasing the likelihood of flares from that sunspot as well as coronal mass ejections from this area, sunspot 2839. There's a lot of filaments, a lot of plasma in between the sun and the earth right now, and we are expecting it to eject in the next 24 to 48 hours, probably more like 24 hours if I had to guess, which I don't. You can see some of the filaments here. You can see some movement happening. We don't see a coronal mass ejection yet on the coronagraph imagery. When it happens, we'll let you know. Anyway, here's that same time period in 304 angstroms, which is ionized helium from the Solar Dynamics Observatory. And we'll blast through a bunch of data here to show you what's going on in the environment. So here's the current state of affairs in the solar system. We'll advance this 1 week. There's where things will be on July 12th. The 10.7 centimeter radial flux has dropped down to 91 solar flux units, surprisingly. And there is the 1 year chart of that. The black line here is the 10.7 centimeter radio flux, the radio output of the upper chromosphere and lower corona. No solar storms or geomagnetic unrest or anything like that forecasted according to the Space Weather Enthusiast dashboard. That's the NOAA forecast. Nothing exciting about to happen in the next couple of days. And let's talk about seismicity. We're seeing a massive earthquake drought, and this is the bar graph showing major quakes for the year 2020. And if you look, you notice all those red bars, those are 7+ magnitude earthquakes, and you can see how often they happen. Here's the last 90 days. We've seen only one 7+ magnitude earthquake in the past 90 days, so if you're in an earthquake-prone zone, please have a plan, because earthquake droughts tend to end in large earthquakes. Obviously, it's a statistical analysis. So here are the 4+ magnitude quakes over the past 24. From volcanodiscovery.com's sort by magnitude feature, which is fantastic, by the way. And there are the 5 magnitude quakes, all occurring south of the equator here. Let's run up the list from USGS. And before I do that, I just want to draw in this little earthquake risk area. These are the places you're most likely to see a major quake. If you're in a zone like that, I'll also draw in Cascadia a little bit and California. If you're in one of those zones, know which building facades may collapse if you're going to evacuate. Have a bug-out bag. Realize what will occur if the power goes out for a couple of days. Try to be an asset, not a liability, in the event of a disaster. So there's one of those 5 magnitude quakes. It was a 5.1 in Indonesia at a fairly shallow depth here, 20 kilometers depth. 5.2 also occurred here at the South Sandwich Islands region. near the South American/Atlantic plate boundary. That's actually the Antarctic plate and the South American plate boundary. I apologize. I'm not a geology expert, folks. Small deep quake in Ecuador, a 4.3 magnitude at 168 kilometers. Estimated depth for that. There was a 4.9 at Vanuatu. Also a deep quake at Vanuatu, north of the 4.9 we just mentioned there. That one's at depth 123 kilometers, estimated depth for that one. And continuing up the list here, the earthquake lull continues. Let's check volcanoes, starting with thermal imagery of Mount Etna. As Mount Etna has created a new southeast crater, there is the thermal imagery from some lava fountaining happening at that. That happened yesterday, July 4th. So less than 3 days since the last paroxysm. Early morning last Friday, another similar eruption occurred yesterday afternoon. Strombolian activity resumed at the southeast crater, quickly increased in a lava fountain. After cessation of lava fountaining, intermittent weak Strombolian activity continued at the crater for a while before stopping as well. Tal, which has been creating some fog in Manila, actually, has reached the highest sulfur dioxide levels ever recorded at the Tal volcano. Not a good sign, an indication that it may erupt in spectacular fashion. Having sulfur dioxide levels reach 22,628 tons per day, again, the highest level ever recorded. Over doubling its July 2nd outputs in terms of sulfur dioxide. Luatolo exploding, 7,000-foot ash plume there over the Lesser Sunda Islands. Semeru producing a 14,000-foot ash plume over East Java, Indonesia. Fuego exploding, producing a 15,000-foot ash plume over Guatemala. Revenador exploding, flight level 150 there as well. It's a 15,000-foot ash plume over Ecuador. Sabancaya exploding, producing a 21,000-foot ash plume over Peru. And Novato State Chilean were unable to detect whether or not it's erupting. Please don't pole vault the caldera, as it could be erupting. This public service message brought to you and stupid people at smAshomash.com. Of course, you're not a stupid person. You're viewing our videos. How could you be? We try to keep you informed. Let's move on. And the next thing to cover here at Smash News Network, least busted name of news, is the X-ray flux. So we still see this X-class flare, the largest flare since September of 2017, having been produced on July 3rd. Peak flux occurred at 1420 Universal Time. There were also 3 M-class flares, all from the same sunspot there, Sunspot 2838, which spontaneously appeared on the northwest limb and then set quite promptly. Since then, pretty calm conditions, and there is a significant solar flare watch in effect because of Sunspot 2839 and Sunspot 2835 especially. No spikes in the GOES proton flux except for this little tiny event here. Some relativistic particles were sent to Earth as a result of this X-class flare. And there you can see that little tiny signal there in the proton flux. Those are relativistic protons, which only took a couple of hours to arrive. Here's the GOES magnetometer over the past 3 days, and we can expect to continue to see spiky readings here. The Earth is in a solid South Pole-oriented current sheet, and I expect it to remain there. Just keep in mind the magnetic environment can suddenly change. That's why we can suddenly see sunspots form all spontaneously and produce X-class flares with absolutely no warning. Keep in mind the data was 1 hour old when we made the video. And again, Earth is in a South Pole current sheet shown here in red. North Pole-oriented current sheet shown in green. Here's a line-of-sight ecliptic plane field plot essentially the same data from a different perspective. It also shows the solar magnetogram. And our last Gong 2 imagery will be the line of sight coronal hole plot. There you go. There are some coronal holes here. Some coronal holes associated with both poles. And there is one in the Earth-facing portion of the solar disk up north here. It looks like it's a South Pole-oriented coronal hole, according to this ASSA detected coronal holes plot, which you can look at yourself if you like at the Integrated Space Weather Analysis. The Integrated Space Weather Analysis Center, excuse me. So Sunspot 2837 is looking pretty weak here. I'm not even sure if that's still a sunspot. We'll analyze that at the end of the video. Sunspot 2835 is huge, although it only has one very large umbra. Sunspot 2839 is a little better balanced, and we're seeing some migration of the leading umbra there, the leading North Pole umbra, increasing the probability of solar flares and coronal mass ejections associated with Sunspot 2839. It's the one to keep the eye on. And when I say eye on, well, the pun is intentional. Geomagnetism looking calm here. KP index of 1 over the past 24 hours, or over the past 6 hours, rather. And next, looking at the real-time solar wind to see the BZ has just shifted into negative territory. And that does increase the geo-effectiveness of incoming solar protons, which are at a slow and low level anyway. But there you go. The phi angle steady here over the past few hours. The BT-BZ just shifted. So the BT is at 7 nanotesla, and the BZ is at -1 right now. Current solar wind density only 4.55 protons per cubic centimeter. Solar wind speed 333 kilometers per second. Pretty slow and diffuse solar wind there. Again, the main feature is that BT-BZ shift. And when the BZ shifts into negative territory, it makes the solar wind more geo-effective. Speaking of geo-effective, here's the space weather modeling framework for geomagnetism around planet Earth. It's the magnetohydrodynamic pressure. And it's 4 hours of data if all is working according to plan, and it looks like it is. See a little reduction of the pressure there. Pretty low pressure environment there at the moment. Here are ground magnetic perturbations. Since a lot of people on YouTube are very, very scared and spooked over polar excursions, geomagnetic excursions, we show this data daily to show where changes in Earth's B field are occurring. That's what we mean by geospace delta B. Changes to the Earth's B field. The B field being the magnetic field that goes through a magnet. We showed you the sun's. Here are changes to the Earth's geospace delta B. This is nanotesla, by the way. The previous frame was in nanopascals. Nanotesla is the magnetic flux itself. Nanopascals are magnetohydrodynamic pressure. Anyway, that's 4 hours of data. Nothing too exciting happening there. By the way, we do regularly stream live to Twitch. Check out the mobile app as well, twitch.tv/smAsho if you haven't done so. It's a fantastic mobile app, and Twitch is probably the world leader in live streaming technology. Also, if you enjoy the content over on YouTube, press like and subscribe over there. Most of our content is there. If you're viewing the videos anyplace else, make sure you view them on YouTube, as you're missing most of our content. Also, there are countless videos and playlists that you may not be aware of. youtube.com/smashomash/playlists. And we already uploaded a meteorology segment today. Here's a teaser from that. I mean cold water, not warm water. Cold water, anomalously cold water. Anomalously cold water, mentioned in our meteorology segment. We're also on BitChute, and there's an image of some anomalously cold water. We're also on Discord, and you can find links to that on our homepage, as well as links to this. Today's featured product is the Vaccinate This t-shirt in blaze orange. I'm wearing one right now. Since my vaccination status is none of your business. And the HIPAA laws have not evaporated. The Health Insurance Portability and Accountability Act of 1996 has not evaporated. It's still in place. Your rights have not gone away because of a scary, spooky pandemic. And nothing says don't run me over or shoot me like blaze orange clothing. Again, you can link to that at the homepage, smashomash.com. Smasho merch is the link for that. You'll also find our Discord link down here, as well as the rest of our social media on the home page. Next, thanks to our patrons, the true source of funding for the content, as YouTube ensures that we make just this side of nothing on the videos. We have not even reached 2,000 subscribers yet. So please consider becoming a patron at patreon.com/smAshomash and increase the probability that these videos will continue to exist, remain publicly visible, and free for all to view. Thanks again to our patrons. Again, the URL is patreon.com/smAshomash. Today's cosmology segment, which is a regular feature of the Smash News Network, least busted name in news, will be a separate video not integrated into the daily space weather, as there are too many interesting things to cover in both fields. So make sure you check that out. Also, again, you can find all of our playlists at youtube.com/smashomash/playlists. The electrons that surround Earth in the Van Allen belts have the capacity to charge up satellites, but they're not doing so right now. Everything pretty clear out there as far as charging hazards. None shown in the graphics. Here's the one-year chart of the electron flux, the relativistic electrons that surround planet Earth. Here's the 3-day chart of it, as measured by the GOES 16. And by the way, they're measuring the electrons at the F ionosphere layer, which is largely the bridge between space and Earth. Here's the total electron content forecast. That's not the total electron content forecast. That's the relativistic electron forecast model. And NOAA forecasting a slight downtick here in the electron flux. I have no argument there. Here's a total electron content forecast showing you the entire air column and the electron density therein. I'm going to let it play through a second time, as this will show you where GPS errors are more likely to occur. And we're seeing some anomalies here in the southern hemisphere, both in the total electron content and the ionosphere. We'll show you the ionogram momentarily. In the meantime, we'll let this play through a second time. So these electron blobs can cause GPS errors, and you can see some anomalies there south of the equator. Here's a diagram of the Van Allen belts. Feel free to pause the video. And here is the ionogram, again located at about 300 kilometers of altitude. It's the bridge between space and Earth, and you're looking at vibrational frequency in megahertz, millions of vibrations per second. And we're seeing some anomalies south of the equator once again. We would expect the most high vibrational frequency zones to be north of the equator, as it is northern hemisphere summer. But we're seeing large blobs of high vibration south of the equator here. So that's that. The anomalies aren't as major as we've seen in the past, but you can see some here in places like the South Atlantic, southern Africa, southern South America. As well as the South Central Pacific. Anyway, there's the latest image from 10 o'clock, 10:30 Universal Time, of the F ionosphere layer. And again, folks, we did do a meteorology segment today. There is an entire playlist for our meteorology segments. Make sure you check that out. It's probably the most timely videos that we put out. And speaking of timely, here's the latest series of hydrogen alpha images from El Teide, Spain's ground-based solar observatory. You're looking at hydrogen alpha filtration here. And there you can see sunspot 2839 and sunspot 2835. As well as this, I think it's only a plage now. Analysis coming. First, the thematic map here, part of the GOES 16 SUVI. Get that size correctly so we can get the date stamps. There we go. There are the date stamps. Some minor crown prominences once again showing up here. Again, coronal mass ejection watch in effect. And we'll let you know when that releases. I won't say warning, but we're as close to being between a watch and a warning as we can get at the moment. No, I can't tell you how I forecast coronal mass ejections. Not yet, not until we submit a paper on it. So this sunspot is still a sunspot, barely. Sunspot 2835 has continued to degrade a little bit, and it looks like it's moving toward the realm of becoming an alpha class sunspot. 2839 is the most interesting one, as this North Pole leading umbra has been migrating away from this South Pole trailing umbra. And that increases the likelihood of solar flares. Could be another one forming up here, but it doesn't really look like it. Anyway, there's the magnetic situation for 2839. Let's take a look at 2835 as well, and you can see barely any non-South Pole oriented umbra. So there's a little umbra down here, this little North Pole one. The main umbra is large and in charge. It's South Pole oriented. And last but not least, here is the closest star in 171 angstroms ionized iron from the Solar Dynamics Observatory. It remains my favorite wavelength. What's yours? Leave us a comment and let us know. And may that solar wind be at your back.